will transition to our last speaker, Tim Tomlanovich, who is an instructor in civil engineering technology. And I'm going to stop sharing and go to the speaker view. There we go. So we can
Hello.
hear from Tim.
Hello, everybody. Good afternoon. So my name is Tim Tomlanovich. I am a professional registered civil engineer in the state of Wisconsin and the state of Michigan. I used to be registered in several other states. Civil engineering, when you look at it, it's actually is involved with gas utility architecture. We actually, it's kind of interesting when you look at the programs you just heard about today, is that, believe it or not, us civil engineers were involved in that. Like Tom said, and Tom, we're a integral team. So we're involved in more on the front end stuff, the design stuff. Civil engineer, our first president was a civil engineer. There's different branches of civil engineering: geotechnical, structure, transportation, water resources, environmental, and survey. I am a geotechnical engineer. So basically, my famous analogy is the Leaning Tower of Pisa. Is why is it leaning? Is because of the soil. So I engineer soil, and I engineer from the ground down, foundations, concrete. So my career path was, I got an associate degree in architectural design because I thought I wanted to be an architect because my family was in the um, construction business my whole life. And then I actually ended up working for a civil engineering firm doing CAD work, AutoCAD. Dating myself, it was one of the first versions of AutoCAD, doing drawings, and then they needed extra body to go on a drill rig and do construction observation. And that's when I really was watching like how they were taking soil samples and doing compaction and watching the construction process. That really got me interested in civil engineering. I found out what civil engineering was, especially on the geotechnical side. Like, how do we engineer? How do we make sure that building is staying up? How do we make sure that Leaning Tower of Pisa isn't leaning over? So 4 years of doing that, I actually went back to college at Michigan Technological University in Holt, Michigan. I got my bachelor's and master's degree in civil, and my master's was in geotechnical. I ended up going back to the same firm and got to work on you name any project all over North America: dams, transmission lines, commercial buildings, failures of dams. I was up in Canada working on the oil sands up there, because typically when you look at most projects, they start in the ground. So we're dealing with soil somehow, some way. We're supporting buildings on the earth, basically. So I did that for 15 years, worked with some amazing engineers. I love, teaching because I had some great teachers. I actually got to work with the engineers that designed and did the geotech for some of the tallest buildings in the world. So I feel really privileged about that. And then NWTC came. I got just got tired of traveling, and I wanted to raise my family. So here I am at NWTC. So that's kind of a little background about me. I love rocks. I love dirt. So, um, civil engineering technology is a very unique program. It's actually two programs in one. So I teach the civil engineering courses, and then there's actually a survey side of the world. So there's actually surveying, which is involved in everything. So surveying is actually using robotic GPS stations, locating things out in the field, locating the gas lines before Tom Hebert is actually installing them, architecture, all that. So there's the surveying side of the world, and they do AutoCAD and Civil 3D, and that's one career path. And then the second career path in the surveying is they call them a survey technician. Is when they're out in the field, they actually have to gather the survey data, gather it in a GPS data unit, and they actually bring it back to the office and they download it in the AutoCAD Civil 3D, and that's what makes the construction drawings and locating utilities. Working with the architects and all the utilities. I mean, it's an integral part of all of this. So that's another career path. The person actually out in the field gathering that data. The third career path is the civil side. So I teach here at NWTC. I teach It's called cemented aggregate mixtures. So when you look at concrete is the most worldwide used construction material around the world. So when you look at concrete, there's three main ingredients. That is aggregate, water, and cement. Cement is the glue basically that's holding the aggregate that creates the strength. It's kind of like the backbone. It's kind of like the bones in your body. If we didn't have aggregates, cement's pretty weak. Our buildings would fall down. So we spend a great, believe it or not, there's a great deal of engineering on the aggregates, especially local bedrock sources. I go all the way back to grade science, three types of bedrock: igneous, metamorphic, and sedimentary. So basically, they blast all that out of the ground, they crush it and make it the size, and we analyze the properties to make sure our concrete's going to last for construction. And then the same thing with asphalt. So there's concrete roads, concrete buildings, and there's asphalt roads. There's two ingredients in asphalt: aggregate, and you got the bitumen or the asphalt. And the asphalt is the glue that holds the aggregate structure. Same kind of thing. We have to spend a great deal of time of engineering. And then the third thing that I teach is soil mechanics. So when you look at a construction site, if you ever been on when the 41 mega project, there was lots of earth being moved around, embankments being built, soil being moved around, and then we actually have to measure the in situ strength of those properties, and we have to make sure that that soil is properly placed and compacted so we don't get settlement, undesired settlement, and sinkholes or the leaning tower of Pisa. So there's a great deal of engineering the soil and engineering aggregate. So I also teach in the civil engineering technology program. I teach statics and strength of materials. That's very similar to what Tom in the architectural. We teach, they take physics and we understand how loads are transferred down into the soil. I actually teach Tom's students on the structural analysis side of the world. We also deal with water resources, water technology, stormwater, sanitary sewer, because typically our civil engineers, we're designing sanitary sewers, we're designing gas lines, we're designing stormwater ponds, we're out there surveying, gathering that data, and we actually have to size the pipes and locations. And and I also deal with construction methods and engineering inspection. So basically, our students, it's a very hands-on program. Basically, they're out in the field or in the lab or in the office doing AutoCAD. We're the eyes and ears of the registered professional engineers. So basically, our students are out there gathering that survey data. They're out there inspecting the construction. They're in the lab testing everything to make sure everything is installed according to how it was designed based on that plan set. So a lot of times our students are observing, like students like Tom Hebert's, making sure they're actually installing it the way the plans and specs say they need to install it. So that's kind of a third career path. So that's a little bit about the program. We are also ABET accredited. So what that means, we're the only ABET accredited 2-year associate degree in the state of Wisconsin for civil engineering technology. What that means is to become a registered professional engineer or a registered professional land surveyor, you have to graduate from a accredited university. Either it's 4-year or 2-year. So because only Wisconsin, because we're a 2-year accredited program, our students can sit for the professional surveying licensing exam and a professional engineering exam with more education. Otherwise, similar to Tom, if they want to practice in another state, they'll have to get it. They can move on and get their bachelor's degree. So our students are 100% graduation rate, 100% in the field. Average salaries between $45,000 and $50,000 a year starting. They do an internship every week. My coworker Mark Kameen, he's the survey instructor. We seem to be getting emails, at least 2 or 3, from just employers in Green Bay looking for our students because they need those hands-on engineering technicians. They call them civil engineering technicians to to build infrastructure. So my last thing here is when you build infrastructure, we look at our infrastructure, it's getting older. We need to replace it. Civil engineering will never go away. Our cities are getting bigger, population is getting bigger, infrastructure is getting older. Civil engineers are involved from start to finish somehow, some way. So that's a little bit background on my program.
Very cool. That's a lot to take in, but great connection to infrastructure. We're hearing a lot of that right now in the political end of things because they're talking
Yes,
about what's infrastructure and what's not. I mean, how fascinating to know that has a direct connection to your program.
absolutely.
I would not have even thought that.
Yes, and you know our students they're all over the United States. They can go they go across the world. So it's pretty amazing. It's a very valuable versatile program. If you love being outside and love that engineering mind, how things are constructed, this is it. So
I'm trying to come up with an intelligent question, and I don't even know what I don't know. But I was a farm girl, so I have made some concrete in my day.
okay.
So when you are constructing, when you're using concrete for a building, for example, what do you estimate is like, obviously we would love that to last forever. What is in the program? How do you figure out like how many years is this concrete going to be structurally sound, for example?
Right. So typically a design life is 50 years.
Okay.
Is typically when we do our structural calculations and our concrete calculations. Um, it's 50 years. So yeah, when we're engineering our aggregate properties, there's aggregate properties like our local limestone, dolomite in the area. There's chert in there, which is very detrimental. It decays, and you see pop outs when you see that expands especially in our freeze thaw environment. So yeah, so when you have a lot of that, we're dealing with a lot of that now, like the dams on the Fox River. I was involved in that project. They were deteriorating because basically back in the 1900s, they dealt with what they had. There wasn't really engineering, so they basically blasted it and crushed it and made the dam. So now we're trying to figure out, okay, how much longer will that deteriorate, or do we? That's why you saw them replace a lot of the sections of the dams out there. So yeah, it's 50 years to answer your question. Is typically a design life. Roadways, for pavement thickness. That's how they call it a life cycle cost, and they have to determine, okay, this asphalt's done. We need to either tear it out and replace it or patch it. It's all those decisions. So
Great. Allison, do you have anything?
I don't know how to ask this question. However, bear with me. So, the ground in Arizona is different than the ground in Wisconsin. So, do you teach to that? Do like I don't even know what to ask, but just
yes.
thinking about the differences.
Yes, absolutely. So there are, I teach actually soils, there's different soils all over the world. So there's basically four different kinds of soils. You got sand, clay, gravel, and silt. There's four main ones, and there's a universal soil classification system. So yes, so like in Green Bay, we deal with a lot of clay. It gets sticky and wet when you're trying to dig a trench. I'm going to engineer that differently than in Arizona when it's all sand. So yes, we basically when we just did a sobering up in the utility substation. Reason why we do a sobering is we engineer what's in place. We determine what kind of soil that is, what kind of soil it is, and then from there we do in situ measurements of strength of the soil, and then we take it to a lab, and then we figure out, okay, what kind of foundation is it? Shallow? Is it deep? We give construction recommendations, especially in the gas utility. Okay, water's 2 feet below, and they got to dig 6 feet. They don't. How do we deal with that? Clay was less permeable than sand. So, Tom, I'm Tom Hebert. I'm sure you've been in below the water table trying to install a gas line. That's geotechnical engineering. That's what we're there for. We're usually involved in that process to help that construction process go on, and that's what our students are doing. They're out there watching and observing that.